Hi everybody, welcome to our week 11 quiz tutorial. This week you guys were simplifying rational expressions and multiplying and dividing rational expressions, so that's exactly what you saw in your week 11 quiz. So the first one I asked you guys to do was to simplify x squared minus 6x plus 9 over x squared minus 9. The first thing for simplifying is always to factor first, so that's what we're going to do, because as much as you guys are going to want those x squareds to cancel, they don't. Okay, I promise you that line in the middle is division, and division does not undo subtraction or addition, I promise. We've got to get it to be multiplication first. Okay? So factoring it out will make it multiplication so we can actually divide things out. Okay? So factoring first, in the numerator, that would be x minus 3 times x minus 3. In the denominator, x squared minus 9 factors as x minus 3, x plus 3. Okay. Once it's factored, then it's actually multiplied out, so now we can divide things out. We're dividing out common factors. So what I notice is I have an x minus 3 divided by x minus 3, and anything divided by itself is 1, right? So x minus 3 over x minus 3 is 1. So now we have 1 times x minus 3 over x plus 3, which would just be x minus 3 over x plus 3, and we are done. So in general, with simplifying, you factor first, you divide out common factors, and then your answer is what's left over. You can leave these in factored form if you have more than one factor. Okay? Next up is about undefined factors. So in general, we can't divide by 0, so that's actually what you're looking for the undefined values, okay? So I don't actually care about the numerator, I care about the denominator, because that would be divided by 0. So if I factor out that denominator, because I would say this denominator, it can't equal 0, and if I'm solving it, I'm going to have to solve by factoring. So if I factor it out, I'd use that guess and check factor technique. It would be 2x minus 7 and x minus 1. And so that denominator cannot equal 0. So then I'm setting each factor equal to 0 and solving it. So I'm going to say 2x minus 7 can't equal 0. And x minus 1 can't equal 0. In solving, I would add 7 and divide by 2, which means that x cannot equal 7 halves, or 3.5 or 3.5 for those of you who like mixed numbers or decimals. Okay? And x can't equal 7 halves, and x also cannot equal 1. So my values for which this expression is undefined would be 7 halves and 1. Okay? It would be these two values right here. Okay? So in general, what you're doing to find undefined values is you're saying that the denominator can't equal 0 and solving. So it's setting it equal to 0 and solving for those values, because we can't divide by 0. Next up, multiplying. Multiplying, it's a lot like simplifying, because all that's going to happen when you multiply is that the numerators multiply together and make one big numerator, and the denominators multiply together, which gives you one big denominator. So really, if you factor it out first, we can simplify by dividing out common factors, and then multiply the rest together. So let's do that. So in the numerator, it's x plus 4, which is x plus 4. It doesn't factor at all. The denominator, the first one, is 16x squared. And what you can do is actually separate it out into its prime factorization so that it's easier to find all those factors. So 16 we know is 4 times 4, and each 4 is 2 times 2. So I can write that as 1, 2, 3, 4 2's multiplied together. The x squared would be 2 x's multiplied together. Okay? In the second rational expression, I've got 4x squared minus 8x in the numerator, and I have a GCF there. 4x squared and 8x are both divisible by 4 and by x, so I can go ahead and factor that out. So that would be 4x and x minus 2. In the denominator, I've got x squared minus 16, which is a difference of two squares. So that would factor as x plus 4 and x minus 4. Now that I have things all factored out, you can start looking for common factors that divide. Now keep in mind, for them to divide out, one has to be in the numerator and one has to be in the denominator. If they're both in the numerator, they multiply together. If they're both in the denominator, they also multiply together. But if there's one in the numerator, like I notice an x plus 4 up here, and an x plus 4 down there, they're going to divide out, okay? So they have x plus 4 divided by x plus 4 is 1, okay? What else can I divide out? Well, I notice I have an x and an x, so I can divide out one of my x's. 4 is 2 times 2, so what I can do is divide by 4 and divide by 4, which would be 2 2's. Now that I've divided out everything I can, my answer is going to be what's left over. So in the numerator, all I have left is an x minus 2. In the denominator, I have 2 times 2, which would be 4, times x, which is 4x. And I also have an x minus 4. If you want to distribute, you can, but factored form is just fine for all of these. So you can always just leave them in their factored form and just be done. If you ever don't have any factors left over in the numerator or the denominator, there's a 1 there. Okay? So remember that when you divide it out, x plus 4 and x plus 4, they divide to equal 1. So you'll always have a 1 somewhere. Okay? Last one was a division problem. So first thing with division problems is making it into a multiplication problem. So you multiply by the reciprocal. So what that looks like is that the first rational expression stays the same. We have 28x to the third y to the fourth over 7xy. And division is the same thing as multiplying by the reciprocal. And the reciprocal, it's a really fancy word, but what it looks like is that your numerator and denominator are going to switch places. So the 35y to the third is going to go in the numerator, and the 16x squared y squared goes in the denominator, okay? It's doing the opposite operation. Instead of multiplying by the 16x squared y squared, we're going to divide by it. Instead of dividing by the 35y to the third, now we're multiplying by it. So that's what it is. It's the opposite operation. From here, it's going to look like number 3, except we have all monomials, so we're just going to expand everything out so we can see what we have. Okay? So the 28 is 4 times 7, and 4 is 2 times 2, so that would be 2 times 2 times 7. X to the third would be 3 x's multiplied together. Y to the fourth would be 4 y's multiplied together. In the denominator, we have a 7xy, and that's not going to separate anymore because 7 is prime, and we just have 1x and 1y. Alright, in the second rational expression, I have 35, which is 5 times 7. I've got y to the third, which is 3 y's multiplied together. In the denominator, I have a 16. So 16 would be 4 times 4, and each 4 would be 2 times 2. So I'm going to end up with 4 2's for 16. X squared is 2 x's multiplied together. Y squared is 2 y's multiplied together. And once everything's kind of listed out like that, you can see what divides out, okay? So let's see. I like to just pick somewhere to start. So if I pick the denominator, so do I have a 7 to divide? I do. So I can divide out a 7. Do I have an x that I can divide out? Absolutely. We can get rid of one of the x's. How about a y? Yes, I can get rid of a y. Okay? Hopefully that's kind of clear. Okay. Let's see, next denominator. I can divide out actually 2 2's, because there's 2 2's up here and 2 2's down there. I don't have any more 2's though. I can get rid of some x's by dividing those out. So divide by 2 x's and divide by 2 x's. and divide by 2y's, and divide by 2y's. And I think that's all I can do. Okay? Then I can just remultiply everything together. So in the numerator, what I have left is a y, a 5 times 7, and then 3 more y's. So 5 times 7 would be 35. And then I've got 1, 2, 3, 4 y's, so that would be y to the 4th. In the denominator, all I have left are these two 2's in the middle, and 2 times 2 would be 4. So there's my simplified answer. Okay? Hope this helps you guys a little bit with rational expressions. Keep working, keep practicing. If you don't have factoring down, you've got to master that first before doing anything else, I promise. So work on your factoring first, and then get to this stuff. And just keep practicing, keep at it. If you have questions, please email them my way. Okay? Good luck this week.